Hello, it is another day. We are going to discuss another subtopic in three-dimensional figures. And today's subtopic is calculation of angles and lengths. Now, in calculating angles and lengths in three dimensions, we also use the concept of Pythagoras theorem and the trigonometric ratios. Therefore, today we are going to see some examples on how to calculate angles and lengths. Okay, example number 1. Given a cuboid below, calculate A, the length LOK, and B, the angle APT. As you can see the figure here, this is a cuboid. Now we have been given the planes, the lines, and the other things involved here. Now to calculate the length LOK, first of all we must let me show you what is LOK. Let me show you what is LOK. Now LOK here is this one. Now if you check the base here, the plane at the base and the plane upward here, they are equal. For that case now, LOK can be equal to TP. As you can see here, let me show you. This one, this line is equal to this line. Now, as you can see here, we are having VP, which is equal to 20 centimeter, and also we have AP, which is equal to 24 centimeter. Now, to calculate this one, we must use the Pythagoras theorem here, which is, let us take this triangle now. Let us take this triangle which is APT. Now we need to have this line whereby TP equals to LOK. So once you get TP, it means you have already got LOK. Then length AP is equal to 24 centimeter, and the length PV, which is equal to AT, is equal to 20 centimeter. Now to get TP, this one will be equal to TA square plus AP square. So we have TP square, which is equal to TA square plus AP square. Now substituting the values of TA, which is 20 square, plus AP, which is 24 square, which is equal to TP square. This one will be equal to TP equals to 20 square plus 24 square, whereby here it is 400 plus 576. Then if you add there, you get 976 square 976. Now the square root of 976 is equal to 31.24 centimeter. Therefore TP equals to that. For that case now, because we are looking for LOK, then since TP equals to LOK, therefore LOK will be 31.24 centimeter. Okay, that was part A. Now let us see part B. In part B, you have been asked to find the angle. Now, angle APT. As you can see, from our cuboid, I have just taken this triangle from our cuboid. I have taken this triangle, whereby in this triangle is where we can find the angle TPA or APT. TPA or APT. Now, to get that one, you can either use tangent, cosine or sine. because we have all the values here which can be used in those trig ratios. But let us use tan. Tan theta. Let us say our angle is theta. Now tan theta is equal to opposite over adjacent. Now our opposite here is side TA and our adjacent is side AP. Therefore, we are going to take the values of those opposite and adjacent so that you can get the value of theta. Now tan theta equals to opposite is 20 centimeter over 24 centimeter. Now if you divide this one, you will get 0.8333. So tan theta equals to that value. Now, in order to get theta, we must have the inverse. We must have the tan inverse of this value so that we can get the angle. For that case now, theta will be equal to tan inverse of 0.8333. Now, reading from our four-figure, you will find that theta equals to 39 degrees and 48 minutes. So this is the value for our angles. Yeah, now let us see example 2. Consider the figure below, which is prism. Find A, length BA, and B, angle between plane FBCE and plane ABEF. Now, as you can see, our figure is here drawn. Now, starting with A, length BE, as you can see, it is here, length EB. And we have length, here we have 4 centimeters, and here we have 3 centimeters. Now, we need to find the length BE. As you can see, we are having a right angle here. For that case now, this will be our hypotenuse. Therefore, to get a hypotenuse line, we just take BE square equals to 4, or let me use letters first, BC square plus CE square. Now, substituting the values of BC and CE, we are going to have BE square equals to BC, which is 4 centimeter square, plus CE, which is 3 centimeter square. Then this one will be 16 centimeter square plus 9 centimeter square, whereby there is no bracket there. So 16 centimeter square plus 9 centimeter square, which is equal to 25 centimeter square. Now, our BE square. Oh, here, BE square. Then we are going to apply the square root on both sides so that we get BE. Then BE will be equal to 5, or let me put like this way, centimeter square. This square will be cancelled, and this one will be 5 centimeter. Therefore, BE equals to 5 centimeter. So that's how we can get the value for BE. The second part is how to get the angle. Angles. Now the angle here required is between plane FBCE and plane ABEF. As you can see from our figure here, we are having a plane FBCE, that one, and also we have plane A, B, F, E. Now here let us start by F then E. So A, B, E, F. A, B, E, F. A, B, E, F. Yeah. Okay. Now taking the two planes, as you can see there, taking the two planes. We can draw here this plane. This one. So we have that plane, and also we have this plane. Yeah, so this is B, this is A, and also we have F here, we have E there, we have B, and we have C. So we have the two planes there. Now the angle required is this one. The angle required is that one, which is made by line EF, which is made by line EF, or which is made by the edge EF, the edge obtained by two planes. When two planes meet, they form an edge. Now that edge can be also used as an angle made by two planes. Okay, now to get our angle here, BEC, our angle BEC, which is made by the two planes, we are going to use this adjacent and this hypotenuse line. Yeah, now the trig ratio which will be used here is cosine. So we are going to have cos theta, which is equal to adjacent over hypotenuse. Adjacent over hypotenuse, whereby our adjacent is EC, which is 3, and our hypotenuse is 5, EB, 5 centimeter. So cos theta equals to that one. Now, in order to simplify this one so that you can read in a 4-figure table, we must put it in a decimal number. So 3 over 5, this is equal to what? Cos theta equals to 0.6. 0.6 can be read in the 4-figure. So theta will be equal to cos inverse. Cos inverse of 0.6. We are going to have 53 degrees and 7 minutes. So that is the angle given by the two planes.